Now I would like to welcome our last speaker for today, Gwen Shapira. She's the principal engineer at Confluent, and she will talk about re-architecting Apache Kafka for the cloud today.
Yeah, thank you so much, Judith. So at Confluent, I'm an engineering leader, and I lead a cloud-native Kafka team. And as part of the role, leading cloud-native Kafka team, it means I get kind of a front row seat for both how our customers and a lot of other companies use the cloud, think about the cloud, manage their cloud migration and cloud architectures. And on the other hand, I also get to see how Apache Kafka and the community is evolving over time. And in this talk, I'm going to bring both of them together and talk about really big industry trends that we are seeing and how evolution in Apache Kafka is aligning with those trends and enabling you to adopt those trends as users of Apache Kafka. So the industry trend I want to start with is the rise of cloud-native data systems. And if I look back 20 years ago, when I started my career as a data architect, if you told me pick a data warehouse, I would probably say something like, okay, Oracle, Teradata. If you'll go to someone with the same role today and ask them to pick a data warehouse, there's a fairly good chance that they will say Snowflake, BigQuery, Redshift. And there is a reason why things shifted. And if we look at all kinds of databases and how people use them in the cloud, you'll see that there is an entire generation of cloud-native databases, all kinds of databases. DynamoDB is key value, Snowflake is obviously data warehouse, Aurora is an OLTP system. All those systems were built in the cloud, either from the ground up or in some cases as a major rewrite of something that already existed. And they were written from the ground up. So the idea is that Aurora is not just MySQL running on someone else's computer. Snowflake is not Oracle running on someone else's computer. The whole idea is that the cloud is just someone else's computer. It used to be a very popular old joke. It's no longer a true idea we can really use in any meaningful way, because all those systems are fundamentally different than the older generation of databases that we know and love. And they're different in a way that makes them more appealing to us as users. That's why we have been making this shift. So obviously defining cloud native is kind of a loser's game. Everyone has their definition. But the things that I see in common for all those next generation data systems developed for the cloud, they do have things in common. And those are the reasons that we use them. The fact that they're API driven, that creating a new database, a new table, a new anything is an API call away. The fact that they are so elastic that often you don't even have to scale them, you just set a policy and you give them a credit card and sublimits and you throw your queries at them, and you know that the queries will run, you know that performance will be reasonably good, and you don't really have to think about how many machines I need. You will only pay for the capacities that you're using. You will not pay for licenses on cores as we used to do until fairly recently. Those systems are very, very often multi-tenant. Like you don't really get your own machines for an S3 cluster, but most of the time we really don't care. And there is an illusion of infinity that you really cannot run out of cloud. Now it's slightly an illusion, and we've run out of cloud plenty of times, like even out of machines in a certain region. But to a very large extent, you feel like you can just always get more capacity if you need it and are willing to pay for it. So we really, really wanted all those new modern capabilities that we know and love from the cloud. We really wanted to bring them into Apache Kafka. But we cannot just go on an existing system that serves us so well for over 10 years and just go start slapping a bunch of random features on top. That is not going to work. So, and the reason it's not going to work is that we know what we love in Kafka. And part of it is that Kafka has conceptual integrity. The idea is that if you understand some basic concepts about the system, you can reason about it, you can understand how it works, when it doesn't work, why it doesn't work, how to make it work again. If you look at some components of it, you can understand them from first principles. You can reason about the design decisions we've made. This is super important for the Kafka community, and we did not want to lose it. And we knew that just slapping features on top of the system will make it lose it, because architectural integrity does not happen by accident. And the core thing that we really didn't want to lose, and that is especially challenging in the cloud environment, is the idea that a system can become efficient and scalable and performs well if you pick the right abstractions to work with, and those abstractions will make everything align. So in Kafka, we have our log as the core abstraction. The idea is that you produce one message after another and they kind of get stored continuously, and we have this one flow going from the customer producer through the network layer in the operating system, through Kafka itself, to Kafka memory, to the consumer. All this entire flow has been optimized with the log abstraction in mind. And because our APIs use this abstraction and our implementation uses this abstraction, and this allows us to basically steer users through APIs and configurations into making their own software work efficiently with Kafka. And you'll see that a lot of Kafka tuning guides are encouraging you to go with the grain, go with our abstraction rather than try to fight it. And if you use this correctly, both us in Kafka and you in your applications, you'll suddenly, all things will work really well. CPU caches will fill up in the right time. The memory caches will fill up in the right times. There will be lookups and read aheads, and a lot of our internal optimizations will just work to make your application more efficient. And this is really the thing that we did not want to miss out on as we migrate to the cloud. Now, we also, in addition to this one big concept, we also have multiple goals that from day one, we built Kafka to match. And we have a lot of those goals. I'm going to just talk about two here because those are especially cloud relevant. And the first one is that from day one, we built Kafka to be company-wide scale. That's starting from our origins at LinkedIn. The vision was that entire company will run on a single large cluster. We hated the idea of silos. We hated the idea that marketing will have their own data, and sales will have their own data, and product will have data, and engineering will have data, and we will never have a shared view of the business and the company. We wanted to really break that and enable people to use all the data in order to grow the business and become more effective. So that was the goal. In order to do that, we had to implement things in a certain way. We needed to implement multi-tenancy almost from day one because we knew that there will be different competing workloads running on Kafka. We knew that but in order to have the entire company, you will probably edit one project at a time. So we wanted to make sure that you can always grow the capacity of Kafka by adding more brokers. And the more brokers you add, the more capacity you'll have. It will grow linearly in terms of CPU, in terms of memory usage, in terms of network usage. We don't want it to be like plan capacity for this part versus the other part. We also didn't want it to be like, okay, as you continue to add brokers, you will get diminishing returns. We want it to be a very scalable system and also easy to scale. The other thing we really wanted, and we kind of just touched on that, is elasticity. So we said that we want you to get more capacity as you add and remove brokers, which means that we wanted it to be easy for you to add and remove brokers. And we wanted the system to adapt as you change the workloads. So if you do more of ETL use case and less of microservices, we didn't really want you to go through a lot of trouble retuning your system. If you do more microservices, less ETL, same thing. And we think we made a fairly good job of that, because if you go to Kafka tuning guides all over the internet, you'll see we have a lot of Kafka tuning guides, but you don't see a lot of tuning Kafka for ETL versus tuning Kafka for microservices. Those general how to tune capacity, you tune capacity for your hardware, for your resources. you change the number of threads, you change some memory buffers, but you don't have to worry about how will those threads be used for specific workloads. This is something that is Kafka actually adjusts to fairly well, putting the resources on the workload that needs them second by second. Now, with all this in mind, I wanted to talk about 3 key changes that we are doing to Apache Kafka that we believe make Kafka even more cloud ready with our basic goals and basic principles in mind. And those are going to be tiered storage, which is going to give us elasticity rather than storage. Kraft, which is our new controller, which is going to help us scale to significantly larger clusters, and multitenancy, which is how you're going to support many different workloads on the same cluster. Starting with tiered storage. Tiered storage is really based on the idea that some of your data is more valuable than others, and it's also used in different ways. So the idea is that the newest data on your cluster is you want to use it in very low latency, and this is your most valuable data. Older data is slightly less valuable, although you may need a lot more of it, and you usually want to use it in high throughput manner rather than necessarily low latency manner. So tiered storage allows you to essentially use different types of storage for new versus old data. The way it works is fairly straightforward. As you write data, after every, I believe, 100 megabyte segment, we take that and we move it to an external storage system. It can be HDFS, it can be S3, it depends. And then most of the time you read and write locally. If you need to read all data, we issue a network read to the cold storage, bring it directly to your client via Kafka. Now, the nice thing that happens, since most of your data, except very small tier of current data, is in cold storage, Kafka is essentially acting as a short-term cache for data. And as such, if you add brokers and you need to move some of your partitions to the new broker in order to take advantage of it, you actually have very little data to move. And this is huge for elasticity, because in the past, if you think about it, you add more machines to the cluster, if you have to move petabytes of data in order to move data to those machines and make use of the new capacity, that can take you a long time. It can take you like a day or two. That's not the best thing ever. In addition, if you think about it, back in the old data center days, adding a machine was something we did like once a quarter. You order machines for the next quarter, you get them, now you add them to the cluster. And if you add machines once a quarter, taking 3 days to move data is no big deal. But today, if I want to add machines whenever my workload kind of fluctuates, it can be multiple times a day, maybe more than once an hour, I have to do it much faster. And tiered storage is what allows us to create elasticity and move things much faster because there is almost no data to move. Now there's more benefits. First of all, because you moved all your history to old storage, you can keep as much of it if you want. Like it used to be that a lot of the capacity calculation on the cluster were driven by if much storage can I afford to keep. Now it's almost free. If you need certain years for tax purposes, go ahead. It's pluggable. Like I know we support S3 and HDFS, but if you have your own favorite storage, if you want to try storing Kafka data on MySQL, go ahead, nobody is going to stop you. And it makes capacity planning a lot easier because you plan separately for short-term, very fast, very high-performance data, and older data that has to be high throughput. Having to do both on the same system was very difficult and something that we were really, really struggling with. Like usually high-performance storage is very expensive, and being able to have very high-performance storage for very little data where it matters was a huge deal. Okay, we talked a bit about tiered storage. Oh, I forgot one thing to mention that is actually a big deal and not mentioned here. Sorry, I kind of mentioned it in passing, but when you read data from local cache, you basically, most of the time you read it from memory. If you read it from disk, it will still be through the Linux page cache because it's still fairly recent data. You may need it again almost immediately. But the really old data, the ones that is stored in the tiered storage, in the slow tier, you it's read via the network path. It never goes through the Linux page cache. It never goes through any of the Kafka memory caches. It doesn't pollute any caching. So you actually have really good separation and isolation between workloads that read old data and workloads that read recent data. And this is also huge for production workloads and multi-tenancy. Now to talk about the new controller. So the main idea here was basically our Kafka's current controller uses a Zookeeper to store all the metadata, all the state about the partitions, the brokers, the configuration, all of this is in Zookeeper. And while Zookeeper served us super well for many years, it also had drawbacks. And one of them is the way that we get data from Zookeeper. So if you imagine if our current controller goes down, when it comes back up, it needs to get the entire state. So it has to read the state from Zookeeper. It can be a lot. If you have a lot of partitions, that is massive amount of data. This is the main reason why you cannot have as many partitions as you want on a Kafka cluster, because the controller has to read all of them and then send the current state to all the brokers. So the more brokers you have, the more the controller has to send all this communication, get back responses. This kind of async communication, we tuned it a lot over time, but we feel like we've reached the end of how much we can tune it and how much we can improve the system. We had to do something better. And the way we thought about it is that when you manage metadata, you actually agree on a shared state in a distributed system. And this is what Zookeeper does. It agrees on a shared state in a distributed system. And this is also what Raft does. And the way Zookeeper and Raft do it is by maintaining a log of all those metadata changes and using the log to maintain this shared state. Now, you may notice that Kafka itself is a system for maintaining state in shared logs. So we kind of looked at that and we said, actually, Kafka looks a lot like Raft. It's almost the same thing. And we believe in conceptual integrity. We believe in logs as a really good data structure to build distributed systems on. And we know it's efficient and we understand it really well. We know how to optimize for it. We know how to tune it. We know how to debug it. We know how to test it. We really want Kafka to become more unified. Why do we need our metadata logs in Zookeeper and our data log in Kafka? Let's put all our data, metadata and all in Kafka, yet let's use Kafka logs for everything. Let's make Kafka a lot more Kafka-like. We really like logs and we want to use more of them. And this really plays to our vision of having Kafka with very few obstructions that are easy to reason about. And if you understand them, you understand everything. And the main thing we gained as a result is the replacement of, it used to be, remember, the controller used to communicate to all the brokers by message, basically request response. Like we would and it would be blocking and synchronous because we needed to make sure the data got there. So it would be, hey, you have a new topic. Thank you for acknowledging my new topic. Hey, you should, did you create all the replicas for your new topic? Fantastic. Let's tell everyone else that you now have replicas. It was high overhead. It was slightly buggy. It's hard to maintain state with retries and everything. And in general, we as the Kafka people really believe that communicating between services via a shared log is more robust, is faster, and it's a generally better way of doing things. So we're very happy that we're bringing our architectural insights from advising to the entire world back into Kafka. And the immediate benefit is that now brokers don't really need to get the state as one big update from the controller in order to maintain synchronization. They can just tail the log of events. So they can just always read the latest. They know what offsets are on. We read up to this point. So we know if they're out of date, if there are changes that they didn't do. It's very easy to monitor that and notice what's going on. We are even looking at automatically fencing. If a broker did not catch up, it means that it has stale metadata. It's unsafe to let it continue. So we can actively fence it and make it stop responding to clients. We can do a lot of really exciting things by having this shared log with visibility. And obviously it means that you only get delta changes every time, so you don't need to deal with this huge state. The state is materialized in memory. We actually take snapshots just in case for recovery. And this optimization allows us to scale Kafka from where it is today to millions of partitions. Right now, we believe we're in the hundreds of thousands. So it's kind of an order of magnitude, or maybe 2 orders of magnitude growth in the number of partitions we can support in a cluster. That's obviously a huge deal. Being able to run all of Kafka in a single binary instead of Kafka and Zookeeper, that's a huge deal as well. It makes local development way easier. It makes all kinds of test systems a lot easier. Cloud deployments a lot easier without those dependencies to handle. So in general, we see it as a huge architectural improvement in Kafka. And you obviously always have this log that is even readable to you if you're like, oh, when this topic get created, who changed, what changed, it's all auditable. Okay, that was a very rushed preview through a very big change in Kafka. The last change I want to talk about is the idea of multi-tenancy in Kafka. And this is actually a fairly old feature. Like the 2 I talked about were introduced this year. So those are like 2020 features, brand new. Very few people are using them yet. You may be the first. No, not really the first, but you can definitely still be an early adopter. For multi-tenancy, I think our first multi-tenancy feature may have been introduced in 2015. So it's definitely been there for a while, but we feel like not enough people think about Kafka as a multi-tenant system. So I want to kind of review what we did in Confluent Cloud in order to support our multi-tenant products in the cloud, and then kind of map it back to what you have in Kafka, because you really have all of it. So first of all, the idea of multi-tenancy in general, the way we think about it, is that suppose that you have 2 workloads, this real-time fraud detection application and this ETL application, and you want to give each one of them a share of the cluster. And in an ideal world, each one of them will believe that they have a cluster of their own, only it's a small one, much smaller than the original cluster because they have to share it with other tenants, but they won't have to know about the other tenants. They will think that they have their own mini cluster. So this is the direction we're aiming at and what multi-tenancy really means to us, this idea of a mini logical cluster for each tenant. And the way we do it in Confluent Cloud is basically with 3 different pillars. Everyone says 3 pillars about everything. We authenticate to a specific logical cluster. So you only have keys and permissions to go into one cluster. We give you your own private namespace. So you only see your own topics. You only see your own consumer groups. You only see your own ACLs, etc. And we apply limits. So we make sure that you cannot really do whatever you want, because this is the way we isolate tenants. Like you cannot use all the throughput of the big cluster. You only get a small slice of the throughput, basically. So the way we handle things like, what if a tenant does list all topics? The way we do it is via plugins into Kafka that allow us to see who is the tenant. In most cases, it would be identified by the user, the principal that the user uses. So you take the principal and you use it as a tenant identifier. And based on this identifier, the plugin modifies the responses. And instead of listing all topics, it will only list return a subset of the topics that belong to that tenant. So in between, as we process the requests, because we're aware of the tenant identity, we can send the correct response. We also do extra validation. If you go in and say alter configuration, again, via a plugin, we can check things like, is a tenant allowed to change this configuration at all? Like sometimes we say, hey, actually number of threads is our decision. You're not allowed to change it. So we reject those. And we also check if the new value is a good value. For example, in the cloud, we decided that you shouldn't be doing more than 8 megabyte messages. And in my opinion, this is way too generous already. So if you try to change your max message size to anything more than 8 megabytes, you will get an error as well. And then, as I said, we apply quotas. And again, it's based on the tenant identifier, in this case, the principal. And in Apache Kafka, you can use either the client ID or the principal. And every time you make a request, the request is validated against the quota metric. You try to produce a megabyte. Do you have a megabyte left in your quota? If you don't, we add a delay to the response. And we basically tell the client, hey, hold off a bit. So we apply back pressure, right? Like, hey, you are out of quota. Please wait a bit until you send the next response. And the client will kind of queue for the next n milliseconds until it has a new quota. Because this is a client implementation and the Kafka protocol is open and a lot of people can implement their own clients. So we don't trust them to actually wait a bit. When we ask them to wait a bit, we also mute the channel. So even if the client sends more requests, we will not accept them on the network layer until the quiet back pressure period is over. And all those things that I just mentioned, these are things that are already have been implemented in Apache Kafka over the years. So you can really see that, okay, if you want to produce and consume and control this throughput, then go and use the configuration added on those keeps. If you want to limit the amount of CPU that the tenant uses, there's another configuration via another keep. You want to limit the number of connections, again, there is a keep for that. Connection rate is super important. It's one of the largest, if you use SSL, it will be one of your largest users of CPU. You definitely want to tune that. So most of what we did in the cloud is some automation, like auto-tune the quotas to and auto-adjust them as needed. So you may get a bit over quota if your cluster is not really busy. If the cluster is busy, you will be pushed down per your quota. And then we also pre-tuned a bunch. We just ran a bunch of benchmarks to really understand how much how much resources we can actually share between tenants. And we know some customers, for on-prem customers, some Kafka users use produce consume throughput. We very rarely seen anyone use anything else, even though we don't know how you can really run a shared company-wide system without it. There is an entire talk on the subject. If you are convinced that you need it at home, there is a link here that you can follow and watch. So all those changes put together, we think really define Kafka as a new generation thing that kind of differentiate old Kafka from new Kafka. We see the new Kafka is far more elastic. You could always add brokers, but now you don't have to add them, once a week at the most. You can add them every few minutes. You can remove them every few minutes. It's far more elastic and therefore far better fit for the cloud, where it's much easier to add and remove resources in general. It's far more integrated in the ways that you can now run Kafka in a single binary. The conceptual integrity is there, and also the integration points to cloud storage systems like S3 in order to use them as tiered storage. And it's far more infinite. You can scale the cluster almost as much as you want because we have better metadata. You can scale your storage more. You can put a lot more different workloads and have them share the same system. So I think I finished just in time. So questions?
Can you hear me now?
Yes.
Okay, great. So actually we do have some questions to you. The first one is, when can we expect Apache Kafka with Craft to be released and ready for production?
Okay, it's two different things. Craft has been released. I believe that version 2.8 of Apache Kafka, which is either already released or is being voted on right now, but I think maybe it's past the vote a few weeks back. This is already out there, and it has a Craft, and it has the Craft documentation. And yes, please install it, please play with it. We do not believe it's production ready, partially because we are missing features. We are missing support for some things that we believe are really important, like not all metadata is already supported. And also things like snapshots are not really there yet, and this is something that is important for recovery. So don't use it in production yet, but we really want the 3.0 version of Apache Kafka to have Craft production ready. Hopefully, it will be the first production version of Craft. And in order to get it there, and I think we're kind of planning 3.0 somewhere in the summer, you can look up the Kafka release schedule in our website. We really need user feedback. You have to tell us, does it work? And we started getting community feedback, which is fantastic. People open tickets, it's using too much CPU, or things that I never thought of even testing. Someone said, if I use Craft with Kafka Connect, we are seeing high CPU. It's fine otherwise. We didn't see any connection. We didn't even think of testing them together, but we found the bugs and they are in the process of being fixed. So we really rely a lot on community involvement and testing. So please download the current release, start hacking around with it, open bug reports, open like even patches and contributions are obviously more than welcome. It's a community project. Like we can only do it with all of us.
Great, thank you. Okay, the next question, maybe dummy question. What does key IP mean?
Oh, sorry. I'm kind of always assuming that everyone knows everything about Kafka. I apologize for that. KIP is a Kafka improvement proposal. So if you want to make a huge change for Apache Kafka, you don't want you to spend a year writing code and then try to contribute it. And then a bunch of committers will say, this does not match our architecture tenants. This does not match what we believe is the right thing for Kafka. Go away. Like this will not be great. So usually people bring up a proposal for the community and they discuss it with committers and they get a lot of feedback about like, hey, did you consider this other method? This is kind of out of alignment with what we normally do in Apache Kafka. This we usually, if you look there, we usually do things in this other way. It happens all the time. And it helps you invest your effort in a contribution that is more aligned with the project and is more likely to get accepted. And because the changes we're talking to are the biggest, they obviously went through very long discussion in the community. And this entire discussion is documented. So you can see a summary in the Kafka wiki, and you can also read all the conversation, questions people ask. If you're looking at the wiki and you're wondering, why do people make this decision? It doesn't make any sense. For example, the decision in Craft to use snapshots. Why do we use snapshots? Why not compacted topics? Kafka has compacted topics. Shouldn't we use them? You can actually find the entire keep with the discussion, with the rejected alternatives. Why did we reject them? What did people consider? What were the pros and cons? So it's a really great way to almost learn how Kafka thinks. And that will help, even if you're just a user, if you know what a feature was designed for, it will help you use it better. So highly recommended to read and.
Great, thank you. And the last question we have here is, what would be the best option to run Kafka cluster company-wide on AWS?
I have absolutely no idea what. Oh, AWS.
AWS, sorry.
What would be the best option? I mean, Confluent Cloud is fairly good. I did not mean to turn it into a sales pitch, but I also can't resist. I mean, you get me to and my team to run it for you, and it has to be kind of the best thing in town. And if you are interested in running it yourself, we can also advise you on, how to pick the correct machines. We run it on EKS, so we use Kubernetes, and this also gives us the auto-scaling capabilities and the elasticity that we need. We've had a lot of experiments with the network layer. Like basically some of the changes that went into the Kafka clients are based on lessons we learned out of experiments with Elastic Load Balancer. You may want to be in a very new client if you're going to use Elastic Load Balancers. We use GP2 SSDs. We tested those extensively. We're now experimenting with GP3s, which are even cooler. So this is definitely a conversation that we can have. There is some documentation on our website, and this is one of our favorite topics because we tried so many things and we know what works and what doesn't.
And another question that got a lot of votes, we are changing from Zookeeper to Craft require many tunings?
That's a great question. We don't expect it to run many tunings, but also not many people did it before. So we don't actually know. Like, you know, for us, it worked out of the box. We didn't need to tune almost anything, but who knows what will be your experiment. So I don't want to answer it definitively just because it's so new. What I can say is that I've just seen the number of configurations for Craft versus the number of configurations for Zookeeper. We're definitely not going to make anything worse. And the main thing is that a lot of those configurations will be familiar to you from Apache Kafka already. Those will be things that you already probably tuned for your other logs. So a lot of it will be things that will be easier for you to reason about versus Zookeeper, which is an entire new system to learn, essentially. And a lot of the bugs that we've seen were really people mistuning their Zookeeper rather than people mistuning their Kafka. I have a great story. I hope I have a few more minutes to share that. Kafka Summit 2016. It was the first Kafka Summit ever. There was an amazing talk by two hilarious Norwegian guys who gave a talk called 101 Ways to Configure Kafka Wrong. And one of the ways that they ran into in configuring Kafka wrong was that they ran an 8-node Zookeeper cluster. Now, an 8-node Zookeeper cluster is not a Kafka misconfiguration. 8-node Kafka is fantastic. You can do it. It will work fine, no problems. But they knew Kafka, they didn't know Zookeeper, so they applied their Kafka knowledge to Zookeeper, and now it no longer works because the 8-node Zookeeper cluster, if you know, Zookeeper needs an odd number of nodes, and usually it has to be like 3 or 5. Beyond 5, it actually doesn't perform very well. So they made two mistakes, one on top of the other. They didn't really understand the ways in which Zookeeper is very different from Kafka. And this is the kind of things that we really hope to solve with Craft. The way you reason about Kafka is the way you're going to reason about Craft. You will just have brokers. You will not need to have anything else in your system, although you could have. You can run the controllers on separate machines. We believe we're going to need it for very high load systems where those controllers will be need every bit of CPU available, but in a lot of systems, we don't think it's really necessary.
Well, thank you so much. That was so exciting. And as a thank you gift, we would like to send this mug to you with the Craft logo and your image on it. So just, you know, the first thing in the morning, you can see this. It looks super cool. So thank you so much again.